So students, we are doing questions from Concepts of Physics by HCVERMA Volume 2, Chapter 3, Rest and Motion, Kinematics. We are doing questions of Objective 2. Fifth question, mark the correct statements for a particle going on a straight line. It's not statements, multiple options can be correct. First part, let us see A. In A part, you are seeing that if the velocity and acceleration have opposite signs, then the object is slowing down. One simple example is that if I throw, for example, I throw this vertically upwards. While going upwards, its velocity is upwards, acceleration is downwards. So, if velocity and acceleration are an opposite sign, if object is going down, yes, its speed is reduced when it goes up. While coming down, but remember, the velocity is downward direction and acceleration is in downward direction and speed will be increasing. So, this A statement is true. If position and velocity have opposite sign, the particle is moving towards the origin. Let us take this B part. Let us take this is number line. This is x equal to 0. This is x negative. This is x positive. If position and velocity have opposite sign, let us say position is negative and velocity is positive. Velocity is positive means that it's in this direction. This body is actually moving towards the origin. That is correct. Whereas when the position is positive and velocity is having opposite sign, then the particle is moving towards the origin. Therefore, this statement is also true. Now coming to C statement. If the velocity is 0 at any instant, the acceleration should be 0 should also be 0 at that instant. Let us take an example, students. This is a body which I throw vertically upwards. At the topmost point, its velocity has instantaneously become 0. But acceleration throughout the journey is vertically downwards. So if velocity is 0 at an instant, the acceleration should also be 0 at that instant. That requirement is not correct. We can say like this, that this is the upward motion, this is the highest point. At this point, velocity is equal to 0, but acceleration throughout is not equal to 0. Now, coming to the D part. So, what we say is that C part is not correct. D part. If velocity is 0 for a time interval, remember, this question is focusing on the motion particle going on a straight line. Therefore, we have to stick to the particle motion in a straight line. So, if velocity is 0 for a time interval, there are the time interval you can take like the particle went like this and then came back. So its displacement is how much? Displacement is 0. The acceleration is 0 at any instant within the time interval. The acceleration is 0 at any instant within the time interval. So students, you can have a forward motion without any acceleration. And after certain time, you can apply the apply acceleration or deceleration, and then the particle will be stopping, and if it is in a continuously in that kind of deceleration, it can reverse back also. So, if velocity is 0 for a time interval, the acceleration is 0 at any instant within the time interval. That is possible. That is possible. So, this is also true. So, here options which are correct are A, B and D. I hope things are clear to you, students.